20 drivers and 10 teams compete annually for the title of world champion. Formula One, or F1, is a worldwide interest. Millions of people watch the sport around the world for various reasons. One of the most attention-seeking facts about the sport is the magnificent speed and agility of these cars. These cars can go to speeds of 220 miles per hour or 350 kilometers per hour. However, what's more interesting is the technology, the science, along with the hard work that's put into manufacturing this car. Given the tremendous speeds that Formula One vehicles may attain, airflow is a key consideration in their construction. As a result, an F1 car's aerodynamics are equally as crucial as its engine. Aerodynamics are useful for three major purposes: lowering drag, producing downforce, and minimizing lift. This is accomplished by regulating the way aerodynamic components like the front and rear wings, barge boards, and diffusers are designed. Well, drag is a sort of air resistant that slows the automobile as it drives. It acts in the opposite direction of the vehicle's relative motion in relation to the air. The body of the automobile is streamed by smoothing down the shapes, minimizing sharp edges, and decreasing the frontal area, all of which assist in minimizing turbulence and drag. Moreover, the aerodynamic elements also aid in reducing lift, or the upward force pushing on the automobile as it drives. It monitors the difference in pressure between the vehicle and the surrounding air as it travels through it. The amount of lift is mostly determined by the form and direction of the car's body. However, the front and rear wings function along with the diffusers below the car to generate downforce by creating a low-pressure region. Downforce counteracts lift to improve vehicle grip and stability, allowing the driver to navigate turns at greater speeds without losing control. Finally, we arrive at the part we've all been waiting for, the most important part of an F1 car: the hybrid powerhouse, better known as the engine. These engines are very sophisticated pieces of equipment and play a crucial role in the speed and performance of a car. The engine specifications are determined by F1 rules. Since 2014, F1 engines have had to have 4-stroke hybrid V6 engines with 1.6-liter capacity and a turbocharger to improve power output. The turbocharger pumps more air into the engine, resulting in increased power. This is accomplished by spinning a turbine using exhaust gases, which powers a compressor that forces additional air into the engine. However, the power produced by an F1 engine is determined by its rotational speed, which has been limited to 15,000 rotations per minute, also known as RPM. In comparison, a road automobile of comparable size typically functions at roughly 6,000 RPM, or half the speed of an F1 car. Well, in addition, hybrid technology boosts the engine's power output. Since 2014, F1 teams have been required by the FIA to employ hybrid engines. The hybrid design has two electric motors, one supplied by a battery and adding power to the crankshaft, and the other managing the turbocharger. This energy is stored in a battery and may be utilized to power the electric motor and increase the engine's performance. The hybrid technology also enables the automobiles to recover energy during braking and store it for later use. F1 vehicle engines are designed to be small, light, and efficient. They can convert 50% of their fuel's energy into power. In comparison, road automobiles can only convert around 20% of the time. Driver safety is paramount in F1, and the materials used in F1 vehicles are chosen with great care. The materials used to assure the driver's safety are subject to severe restrictions. However, the materials utilized must also boost the performance of the vehicle. Material improvements have enabled F1 vehicles to become quicker, safer, more durable, and lighter than ever before. A lighter vehicle improves acceleration, speed, and agility, while also ensuring the driver's safety. Carbon fiber composites are the most often used material in F1 vehicles, accounting for around 80% of the car. Carbon fiber composites have significant advantages, including high strength, lightweight, and stiffness. As a result, they are perfect as chassis building materials. Increasing the temperature and applying tension throughout the manufacturing process improves the degree of the carbon fibers, making them more durable. Ceramic matrix composites and carbon fibers are utilized in the brake system because they have a high specific strength, which means they're reasonably strong compared to their weight. Other materials like titanium are utilized to create crucial components such as suspension and gearboxes due to their high strength to weight ratio. Along with its lightweight and high strength, magnesium is employed in the building of the gearbox case and wheels. Many other important details help in the manufacturing of the car, such as the 3D printers in the workshop buzzing with activity, creating components layer by layer. Additive manufacturing is at the forefront of modern manufacturing, allowing designers to create complicated shapes that were previously thought to be unachievable. This technology enables previously unheard of degrees of customization and performance optimization. This technology is brought into existence by Formula One engineers or modern chemists, combining innovative components with groundbreaking technology. Every component is carefully picked and produced, pushing the limits of what's possible. This attention to detail goes to micron-level precision, where even the smallest variation might be the difference between success and failure. Before a new material is allowed on the racecourse, it must pass stringent tests to verify that it's capable of withstanding the intense demands of Formula One. Engineers use mind-bending models and wind tunnel tests to predict how materials would behave at high speeds and in tight bends. It's a never-ending cycle of improvement, re-evaluation, and testing until perfection is attained. In Formula One, it's not just about speed, but about speed with a purpose. Materials are chosen not just for their strength, but also for their ability to withstand the extreme pressures and temperatures associated with high-level racing. These materials operate quietly and hard behind the scenes to keep the automobile running well. Formula One is the peak of human creativity and perseverance. Designers become sculptors, and engineers become visionaries in this confluence of art and science. It's about designing devices that not only work well, but also inspire wonder. As Formula One moves forward, it's free of the restrictions of the past. It's a world where materials serve as the canvas for goals to be realized. Every race in this world, when technology meets adrenaline, is a monument to the limitless potential of human determination. It's a tribute to advancement, and a demonstration of what can be accomplished when passion meets accuracy. Formula One is more than simply a sport. It represents a look into a future where the sky is the limit.